We've talked about general intelligence, artificial general intelligence a lot now. And if we were to think about an AI system of today, of 2025 and 2026, of the modern AI world, that is closest to AGI, that is closest to what Google DeepMind is trying to build, what Sam Altman is trying to build, and what all of the famous frontier AI laboratories are trying to build. What would that be? Would that be Gemini? Would that be the latest models of the GPT family? No. So that model, the closest, that seems to be the closest to AGI is Nanobanana. So why a simple image generator? Why? And look at Nanobanana and Veo. So the video generator, the 8 to 10-second video generator that can generate photorealistic, so realistic scenes that it's very unimaginable. And same with Nanobanana, it can generate so realistic images of the whole world and around the whole world of all the objects in the world that it is so unreal to imagine. Why does that system, seem to be a system to seem to be an AI system that is closest to AGI? Okay, let's think of it this way. Imagine the first category of models, the language, the large multimodal models, the large language models, right? These models have the capability to predict the next token, right? Now imagine another category of models. Let's call it Cat 1, the LLMs, the LMMs. Now let's imagine Cat 2, the category 2 of models. Let's call them, okay, let's not call them anything, but let's categorize it Cat 2. Now what is it? What is this Cat 2? Now Cat 2 is the model that can reason across multiple dimensions simultaneously, right? So scientifically, we use this term a lot whenever we talk about AGI, that an AGI system should be able to reason across multiple dimensions simultaneously, right? In order to possess worldly wisdom and to be able to think about all the dimensions at once and then reason, right? Now, image generator like Nanobanana, seems to have those capabilities. One of the main reason, it possesses that AGI capability is that it natively supports multimodal architecture, right? What do I mean by that? That it has the potential to process visual tokens and linguistic tokens, language-based tokens, right? Word-based tokens in the same conceptual space, right? So in the same n-dimensional hyperspace. And it is not trying to read the whole world, right? Just like a normal traditional LLM, it is not trying to read the whole world. It is trying to understand the whole world and the physics behind it. That's why we say that it might have or it has reasoning capabilities. It possesses a worldly wisdom, a worldly sense of the physical universe, of the real physical universe, or of the reality, right? The second point that I would like to make about the model's architecture and about the model's features or capabilities is its iterative refinement, right? It can take feedback and course correct itself. And it can allow conversational editing also in the images, right? Now, if we talk about, Nanobanana and its nuances, we have to talk about the world models, right? We have to define world models. So what the sense that I'm trying to make here is I'm trying to, connect the dots of Nanobanana looking forward in the future, not backward, that Nanobanana is something, that we expect out of a world model. I mean, I don't know if it's the whole world model, but it is something or partially a world model, right? Obviously, it lacks physical embodiment, right? It does not have that humanoid structure, that embodiment structure that it can do things for you. It lacks the ability to continually learn, right? We know this stuff, right? It cannot. So after the training is done, we freeze the weights and it does not continually learn from its environment, right? It lacks independent desires, so we cannot expect it to do a lot of scientific discovery, but we cannot expect it to become the best artist that the world has not seen, right? To create something scientifically, to create something mathematically, to create something artistically that the world has not seen, right? So it lacks all of these capabilities. But what we are trying to think is that if we imagine a world model or a model that is closest to the world model, then it might be Nanobanana. So we discussed its capabilities. Now we know that a world model really needs to understand the physical, the spatial, and the causal lens, right, of the world, and all the causal laws of the world, right, that govern reality and that govern the physical universe. And Nanobanana really does that, right? Nanobanana has the physical sense. It understands the spatial structure. behind images and behind all the objects, and it also understands how reality is governed by the laws of physics, right? And all of these cumulatively helps this model reason, right? So that's why we are saying that it has the causal reasoning capabilities in itself. Now we know that it has some or most amount of physics aware reasoning, right? So if I want Nanobanana to create a scene where I'm writing the prompt that a glass is falling off a table, so it will not show us only a broken glass, right? It's going to show us the sequence of motion where the glass is trying to fall or where the glass is falling off the table, right? It understands how liquids behave in the real universe, in the physical universe, right? It understands, how liquids behave, splash and reflect light, right? And it's very important to understand the physical universe. You need to understand all of its objects, right? It's very important for Nanobanana to understand. And we have seen it for the first time in any model, right, of this capability. And the one thing that I like about it is that before it renders a scene, it has the ability to plan that realistic scene that it's trying to render in an image, right? So after we have established that it has physical aware reasoning, we should also understand that it also has very deep spatial understanding of objects, right? It treats a 2D image as a 3D environment. It can understand camera directions. It can also understand object manipulation. Like I can edit an image by using this object manipulation feature. I can tell it to move a chair forward and backward. It understands gravity. It understands that objects possess something that has gravity, universe possess something that has gravity. So if an object does not move freely in the universe, it understands the physical laws that govern the reality of the universe. Now, one more point is that global knowledge and cross-domain knowledge. If I ask it to create a scene of Dubai, right, it will know with precision that I need to create a modern architecture of a city. It will understand the cabs that has been, that has been very common in Dubai versus cabs that has been very common in Tokyo. So it's not going to generate the Tokyo cabs. It's going to generate the Dubai cabs, right, in that particular scene. So it has that worldly wisdom, cross-domain knowledge, and global knowledge without being explicitly trained on it, right? Obviously, it has been trained on massive Google's data set, but without being explicitly trained on a particular scene, it has the ability to generate that scene, to plan that scene, right? And along with VO3, we also see that long-term planning capability is coming into picture, right? So, but what it right now, I mean, what it lacks is that it does not, it might behave like a world model, but it does not have pure independent desires that we can expect it to do scientific discovery for us. Obviously, it's a model, it's a software model. It does not have physical embodiment. Google might create an ecosystem in Gemini where they are catering to all the modalities. They have VO3, they have Nanobanana, they have Gemini, and let's say they have AI lens, and they come up with a humanoid robot, and then together they can call that system very close to an AGI system, right? But right now it lacks physical embodiment. It also lacks the ability to continually learn, right? And there's a lot of research that is going on in the continual learning, especially at DeepMind, right? So yeah, I think it is a great insight, and it's a great mental model to look at Nanobanana and to also slowly understand in which direction we are trying to move. We are trying to understand the aspects of a world model. We're trying to build models that are physics aware, that understand the whole mechanics of all the whole universe, and how objects behave and how liquids and fluids behave, right? And we're also trying to make sense of causal reasoning, the way humans reason the why behind things, right? When especially when we think about the AGI systems, right? So yeah, I hope this video was helpful and it helped you understand how to evaluate and how to think of a simple image generator, and how to also think of an AGI system, right? And what all its capabilities would be, and how far are we, what are the gaps, right? Thank you. See you in the next video. Cheers.